Today we look at the wiring on the layout, including how the heritage line runs on both DC and DCC. Hi everyone, I'm Martin and welcome back to Donnington Castle Model Railway. Now today's video is going to be all about the wiring and the electrics and the control systems for the layout. And I've been meaning to do this video for a long time, but I've been putting it off. I think there are really two reasons for that. The first is that the biggest complaint I hear from other people who do modelling is that they're not any good with electronics. And one of the things I'm really keen for this channel to do is to kind of show that just by getting kind of stuck in and learning and having the right approaches, that you can kind of get stuck into kind of areas and things that you might not be comfortable with. And therefore, I wanted this video to be one that did justice to that and actively encourage people to kind of get stuck in and to try some stuff in this area rather than kind of being fearful of it. The second reason for holding off on this video is to make it interesting. What I didn't want this to be was lots of me talking and then lots of video of underneath of baseboards and kind of wires and things like that, because that wouldn't be, I don't think, either interesting or informative. So as you'll see, I'm taking an approach, showing you some kind of diagrams and some of the approaches I'm taking to wiring the layout up. In particular, in this video, we're going to focus on the heritage line, as that is set up at the moment for both DC and DCC operation, which in some levels is a really easy thing to set up. But then once you start to dig deeper, you find that there are a few challenges associated with that. So I want to take you through my thinking behind how I've got the layout set up. I'm going to put my cards on the table right now. I'm not an electrical engineer. I don't have a background in electronics. The way I've done things is based on a kind of a knowledge, I guess, gained from kind of being involved in tech in terms of kind of architectures and ways of working. But really, I don't know if this is the best way. It works. The layout actually works really well. So it can't be all bad. But if you do have any kind of thoughts and suggestions on how I might be able to improve things, please do add them in the comments below, because I'll be really interested to read them. Now, some of the kind of the wiring itself is not in its final position because I'm still building the layout. So I'm not going to kind of give you an in-depth view of how everything's kind of wired to everything else, but I will kind of talk in principle how I use buses and how I use terminal blocks and kind of the track wiring and things like that. So hopefully, no matter whether you're a DC or a DCC modeler, you'll kind of get something out of this and kind of learn something. But enough waffle to start with. Let's dive in and have a look at the high-level architecture, and then I'll kind of start talking through some of the electronics and the wiring and the control systems in a little bit more detail. And here's a diagram of the high-level architecture. So let me just talk you through this. So the place to start is the top left-hand corner where we have our Digitrax DCS 210+. The reasons for selecting this device and Digitrax as a whole, well, when I got back into the hobby, I did a little bit of research. I was impressed by the range of kind of components that Digitrax made. The fact that this model has USB connection, meaning that I can use JMRI and potentially other bits of software with it, was very useful. And also it came in a very good starter pack with the throttle and things like that. So when I built my original kind of test layout in a spare bedroom before I had access to a garage, this is what I used. And having been out of the hobby for so long, DCC was a completely new thing to me. So this enabled me to kind of really get up to speed with some of the new technology. Some of the downsides, it's made in the US, therefore it can cost a little bit more in the UK, and sometimes availability of stock's not good because obviously it has to be imported over here to the UK. But I have had absolutely no problems with any of my Digitrax components so far. I'm really happy with them. If I were making my choice now, I might pick something different. I'm not sure. I expect at some point in the future, I will start kind of building some of my own hardware components to hopefully include in the architecture. I didn't want to do that from the start because I didn't want that kind of too steep a learning curve to actually just get trains running and to start kind of understanding and enjoying DCC control. So I'm happy with my choice. It might not be the best choice for you if you're kind of starting out on your journey now. So what I would say is to do research, look at some of the new kind of things that have come to market, particularly recently, and yeah, certainly have a good look around, watch plenty of videos, look at plenty of reviews before you kind of decide what you're going to go for. But the DCS unit, so one of the connections on here goes to my programming track. Now, programming track is basically underneath the layout, as you can see. This was actually the first section of track I ever ballasted. So there's absolutely no reason to kind of ballast a programming track. But for me, it was just a good way of practicing ballasting for the first time. And then I did a bit of weathering on that, again, just to practice, the idea being that if I got it wrong, it didn't matter. So that was a little aside. We then have LocoNet connections. And LocoNet is one of the big reasons why I like the Digitrax system from an architectural perspective. And I'll talk a little bit more about the LocoNet setup in a second. For those of you who don't know what LocoNet is, it's effectively, I'll call it out-of-band comms network. That means that the DCC signals don't all have to go through the track in order to reach another component. They can go on a kind of an out-of-band network, and that's really useful. So say, for example, you have a short on your track. If you were relying on that to power things like accessory decoders for points and signals and stuff like that, none of those would work while that short existed. So being able to have this out-of-band network means that, in my case, if I run a loco onto a frog when the point's set in the wrong direction, that will cause a short. But I can correct the short by changing the point over LocoNet, and then that will automatically then clear that short, whereas otherwise I'd have to kind of manually kind of move the loco off that set of points and kind of then change the points over. So coming from a kind of tech background, from an architectural point of view, I kind of really like the idea of LocoNet. I don't believe Digitrax are the only people that use it, but I'm not an expert on anyone else's kit, so I kind of won't try and kind of talk too much about that. But you'll see in a second how I've got that set up when we come on to that on the next slide. And then there was, as you can see on here, there was a USB connection that I run off to an old laptop. That's probably going to get replaced at some point because it's now very, very old. And I use that for running JMRI. JMRI I use to create panels, to control points and things like that, but also for programming, so programming decoders and all that sort of stuff. I'll probably do a separate video on using Decoder Pro, which is part of JMRI, and show you how I add kind of locos, change their addresses, look at different CV values and all that kind of stuff. I'll do that in a separate video. Okay, and then the final kind of output from this is then the track feed. Now, I take that track feed and I put that into a DCC Concepts alpha meter. That gives me a voltage and a current draw. As you'll see in a second, that isn't available when I'm using DC operation. And the reason for that is the next component in the list or in the kind of the chain here is a PM74, which splits my power out into 4 different districts. So originally, before I installed this, I had my alpha meter after this switch, which I'll talk about in a second. And then no matter whether you had DCC power or DC power, it would give you a reading because it's capable of automatically flicking between the both of them. However, once I introduced power districts, if I kept it down here on the diagram between the switch and the heritage line, I would then not get any readings when using any of the other power districts. So unless someone knows a way of doing this that I haven't thought of, I've kind of opted to put this in line between the controller and the PM74. And that way I'm going to see the voltage on the track and the current draw across all 4 power districts. Then for controlling on DC, we have this GaugeMaster 100M controller, very basic, bought off eBay. It only has one power output, but that runs into the back of the switch panel and into the poles of that double throw switch that you can see. Really only use DC control very, very rarely. It's really there for when other people in the family who have DC models that it's either be kind of too expensive or actually impossible to convert to DCC when they want to come run on the layout. So this GaugeMaster I picked up secondhand on eBay, and it does the job really well. But let's come back up to the PM74. As you can see, this splits out into 4 power districts. So I have 3 of these for the kind of purely DCC operated parts of the layout. Power district 2 is for the the Western region main lines, which is the kind of the 4 tracks running around the loop. And I'll show you some pictures of each of these power districts in a second. Power district 3 is then just the Southern region main line, which at the moment is an end-to-end, running from kind of like the left-hand side round the back through the station to the right-hand side. In the event that the layout gets extended, this line is the one that will get extended and would probably then run out round a big loop around the rest of the garage and through a fiddle yard. But that's very much phase 2 and a big question mark over that, so I won't kind of talk too much about that. Power District 4 is then the area that could be a TMD. It's going to be some sidings of some kind. I'm very conscious of not wanting to add too much more track into the layout. There's actually quite a lot of space there. It might not come across in some of the footage, but there is actually quite a bit of space, and so that would be a separate power district. And the main reason for splitting out into power districts is that if you get a short on one of them, then it doesn't kill the others. So, for example, if I've got trains running around on the main line and I cause a short on the southern main line, then all those trains running around the kind of the main loops of the layout are not going to stop running. They're going to keep going. The other advantage of this device is that it also traps shorts. So if I short out, like for example, running over points when they're set the wrong way on one of these power districts, that will get caught by this PM74, which is a whole lot cheaper than this control station. Before this went in, if I shorted, then it would be this control station that would have to deal with that. And that's not a good place for that to be doing that. At some point, that may well cause a problem and blow something. And I much prefer to replace PM74 if that happened than I would this command station. So a few advantages there of that device. And then the key thing for doing to kind of flick between DC and DCC operation is basically just a very simple double throw switch. And I will show you how this is wired in on the layout in a second. But this is effectively an on-on switch. So 2 of the poles go out to the heritage line track, and then the wires from the GaugeMaster go into one side, and then from Power District 1 outputs on the PM74 go into the other side. That means that when you flip from one side to the other, it is one controller or the other that's then effectively sending power onto the heritage line track. That's something for me. That's that's not something you do lightly, because what I don't want is to have a whole bunch of. I prefer not to have a bunch of DCC like the coder fitted locos and things on the track, and then suddenly flip over to DC control and start putting DC current through that. Likewise, if I've got analog locos, I don't really want to flip over to DCC. In actual fact, that way round is probably the more dangerous, because I have. So sometimes it seems to be okay as long as it's not for too long. But I have when just literally putting a DC loco onto a DCC track, it kind of causes the motor to kind of spin one way or the other really, really quickly with the kind of the pulses from the DCC current that alternates. and I've actually burnt out a motor that from literally putting that on for a second. So I'm very, very wary of kind of flicking this switch. But if you do want to control your layout through DCC and DC, then this is all you actually need, is one of these. Now, the caveat to that, and I'll kind of talk about this as we kind of go a little bit further through this video, is that the more things you want to do using DCC, the more challenges you've got if you then also want to have DC operation. If you literally just want to put locos on the track, select either DC or DCC, and then kind of run them around, then really, really easy, no problems. If you start wanting to do things like block detection and control accessories via DCC decoders, via the kind of the track power, then you are starting to get a little bit more complex. Also, if you want spike suppressors on your DCC power bus, or sorry, on your kind of layout when you're in DCC mode, you really want to disconnect those when you're on DC mode. So the more complex things you want to do, the more this kind of idea of flicking between the two becomes more challenging. And that's the reason why only the heritage line works this way, is because I will be doing block detection and all of the kind of things like that. And I don't want the headache of having to think about how that works in DC and DCC operation. Now, there are some other headaches that I've had by doing this with the heritage line, but I'll come on to talk about those when we get to looking in detail at each one of these power districts. And over here, you can see a big box with a question mark saying RFID readers. Now, I saw an amazing video on Wiring Model Railway about using RFID and JMRI to identify and detect where trains are in combination with block detection. So that's something I really want to do. But until I've had a chance to look at the different hardware options, I don't know how that's going to fit in. Now, that might be something I connect up to Arduinos and then maybe get them plugged into LocoNet, or I could do that over USB potentially straight into the laptop. That's a kind of an architectural decision I'm yet to make, but I will get to that at some point. And then that's probably going to be a video all on its own if I do go down that route. So I'll show you everything that I do. Hopefully seeing how all this is wired in makes it a little bit easier to kind of get your head around how this is all working. But what I'll do now is I'll move on to look at LocoNet, because LocoNet is the thing that's doing kind of most of the clever stuff around the layout. And this is the overall LocoNet architecture. So let me talk you through this. So obviously in the middle, you can see the Digitrax command station. Let's just talk about the USB connection first of all. So that USB connection goes into the laptop. The laptop at the moment is using JMRI, although there's no reason why I couldn't use Train Control or iTrain or something like that. It would work in exactly the same way with this equipment. But JMRI, I have the ability to create throttles and also to have effectively kind of wireless throttles. That means that I can use an app on a smartphone to connect via JMRI into the layout. So that means I can either use the handset or a smartphone to control trains running on DCC. I do have one loco that has a HM7000 decoder in it, so I can directly control that with Bluetooth if I flick the decoder into Bluetooth mode, which means that it doesn't touch any of this architecture at all. The loco gets the power from the track still, but in terms of the DCC signals, they're going directly from the smartphone and the Hornby HM7000 app directly to the Bluetooth decoder on the loco. But I won't talk about that too much now. That's maybe something to think about in a different video. But then, as you'll see on the front of here, we have 3 LocoNet connections. Now, LocoNet is, as far as I understand, a broadcast network, meaning that all of the DCC signals get broadcast across all of the different kind of legs of this architecture. It is then down to the individual components to determine whether that message is for an address that it knows about. So if you are, for example, sending a message to change a point via a kind of switch command. That will get broadcast out to every component, but the DS74, which is responsible for that particular address, is the one that will do something with that message. Everything else will just kind of silently ignore those messages. However, they will broadcast them on to anything else that's connected to that other port. So you can just get this basically broadcast architecture. And apparently this works to kind of really big scales. Normally you try and, so for those of you who are familiar with the kind of networking equipment you use in IT for like IP networking, broadcast domains, as they're called, are things that kind of very much you want to try and control because you very rapidly kind of get lots and lots of traffic flowing around, and you get kind of unnecessary kind of bottlenecks and kind of use of bandwidth with all the kind of control messages that flow around. So there are different technologies that get used in that kind of equipment to kind of deal with some of the issues of kind of having to broadcast to everything, which I won't go into now. That's a whole separate kind of conversation. But in terms of LocoNet, all messages are broadcast, and it seems to be that works really well, as I was saying, even up to kind of really big layouts. So certainly for my layout, there's going to be absolutely no problem with this as an architecture. So one of the connections I have goes into the panel that I use. So that's a UP5, and I connect my Digitrax handset to that. And then whenever I adjust the throttle or change a point or do something like that, the messages are sent back across LocoNet via the command station to whichever devices that need to see that. Also out by USB into the laptop, where those messages are also seen by JMRI. So if you're doing stuff in JMRI, then that's kind of how it knows that, kind of what's going on. Another leg at the moment I've got connected purely into the DS74s. The DS74s are what I use to control points. On the heritage line, there are 8 sets of points. And so there are 4 sets of points controlled on each DS74. I will be giving unique identifiers to each of my components as I kind of build the layout. But I've not kind of got all those kind of sorted out at this point because I'm still kind of very much building it. At some point in the future, I will be adding block detection onto the 3 power districts that are DCC only. I'll be using BDL168 primarily, although I might use some smaller ones depending on kind of how many blocks there are in particular parts of the layout. I have one of these already that I used when I was kind of learning about the technology. So I will certainly be using that somewhere. I also have one Digitrax SE8C, which is for controlling signals. So I will be, again, getting that wired in at some point. And then there will be more BDL168s and kind of other block detection units and more signal controllers going in. So they will appear on this diagram as and when I kind of get to that point. But hopefully that gives you a sense of the kind of the LocoNet architecture. And as you can see, there are a bunch of DCC signals that in other architectures would go through the track, and kind of you would kind of wire accessory decoders into your main power bus. Here, as you can see, the messages are going out over a completely separate network, and therefore, even if we didn't have power connected up to the track, we could still change points. We could still detect. Well, we couldn't detect whether blocks are occupied because there'd be no current going through the track. But we could change signals and all that kind of stuff as well. So really useful kind of architecture. So if you are thinking about DCC control, do think about something that supports an architecture like LocoNet, because it can be very useful and give you lots of resilience and kind of flexibility in how you build things. I will run through power districts 2, 3, and 4 very quickly, because as you can see from the diagrams, they're not finished. So this is our Western main lines. Again, these diagrams they're not panels, and they're not intended as track plans. They're just really here to help me document where all the power connections are going. And I'll also, as you'll see from some of them, start to put blocks on here. So then I can start to think about where various hardware devices are going to need to sit on the layout. So this is power district 2, our 4 kind of lines looping around the stations at the top. and then the kind of the embankment on top of the retaining wall is down the bottom. Power District 3 is the southern main line, so it's end to end. I should mention really that the track is in green. Here I've marked on kind of the power bus. The squares with the numbers in are terminal blocks and how many connections are needed on them. Again, this is all very much a work in progress. On this one, you can see the red lines across the track, which is where the blocks are going to be, or at least that's kind of the plan as I'm laying the track, and then nominally where the signals are going to be. But again, that's all subject to change. You can see here that Power District 3, the points that kind of flip onto then the western lines, and that then obviously is Power District 2. And then Power District 4, this is completely fictional because I've got no plans at the moment, but this is kind of the TMD. It's going to go across those two boards, and that's going to be about it. And here you can see the overview for Power District 1, which is our heritage line. Now you can see that the power here is red and black. I've distinguished that from the purely DCC districts because those are cabled with blue and brown, whereas this one, to make sure it's very clear that this is separate, is red and black cabling. Kind of two legs to the bus, for want of a better term. So it kind of splits and goes out around the two legs just to keep wiring down to a minimum. At the end of each branch, there's then a DCC Concepts spike suppressor. As I mentioned before, those need disconnecting on DC operations. That's already a kind of a bit of a challenge when flipping between the two, because you've got to obviously remember to do that. And then on here, I've marked all of the connections to the track and how they kind of connect into the bus. Those 10s are 10 terminal blocks. There was one on each board, and then there's effectively a bus wire between them. You can see an example of one of those here. These are bought off Amazon, and they come in these kind of big 10 block sections, or you can buy smaller ones as well. The brown lines on here show isolated sections. At the moment, everything is just connected into the bus, but then the intention is to have those connections come off to a control panel with some switches on. So when you're in DCC operation, you'll leave them all enabled. But if you are operating in DC, then you can effectively isolate some of the sidings and some of the platforms on the stations and things like that, just so you can have a bit more operational fun. But that's where I'm going to leave it for today. I will come back and kind of really show you how all of this is connected up at a later video, because this video is already quite long. I'm very conscious of that. Just one thing to note on here is you will see that we have all these connections, and the reason for not doing block detection on this network is because each one of those connections, if we were doing block detection, would run into a block detector. And then if we, which is fine on DCC, if we were then on DC, we would probably then have to think about kind of effectively rerouting those onto the main bus. So having some kind of switch that kind of flips between two modes. And it's entirely possible that we'd end up having to have then switches on each of those connections. And then that kind of whole operation of flicking between DC and DCC operation then becomes a real nightmare, because you've got to make sure that you've done everything. Now, there might be easier ways of doing it. And I believe that on some block detectors, they are happy with you running DC current through them. But I'm not really happy kind of flicking between them in that way. So that's why this power district doesn't have any block detection in it. In future, I will show you some other diagrams showing what all of the signaling blocks are and all the wiring for the signals, because that's all separate. There are lots of other things I can talk about in terms of wiring, things like point motors and signals and things like that. But I'm going to save those for future videos. Some of them I'll cover in episodes of Track Talk, and probably a little bit further into the build, I'll come back and do another longer video all about how the electrics and wiring have progressed. I hope you found this video useful. I hope I've achieved some of my initial objectives, which were to kind of just to throw some more light onto this area and to kind of allow you to understand maybe in a little bit more detail the way that kind of wiring can work both on a DC and on a DCC layout. And in particular, if you want to have the best of both worlds and be able to flip between the two. I've talked about the high-level architecture, and I've kind of talked about some of the components and the things that I'm going to be doing with the layout, but also hopefully enough detail and kind of showing you how things are actually wired up in practice. That hopefully gives you some confidence in this area and kind of helps you go away and play around with some of this stuff yourself. Because I think with all these things, the first time we kind of get stuck into this, it can seem really, really difficult and really complex. I think it's just about breaking the subject down and going at it at nice kind of simple steps, understanding and kind of mastering those, and then kind of building up the sophistication on top of that. And I think if you take that approach, then it's very easy to kind of make progress and to feel like this is no longer one of those weak areas, which I know a lot of people say that it is for them. So I hope you've enjoyed the video. Please do leave any kind of questions or comments down below, and I'll answer those as best I can. At some point in the future, I'll come back and revisit this once the layout is a bit closer to completion and all the kind of the wiring's in the right places, and I can give you a little bit more of an in-depth look at how things turned out. But architecturally, I think things are going to stay exactly as they are right now. Okay, so in a second, there's going to be a subscribe button. If you're not already a subscriber, please do consider doing that. It's nice and easy and free to do, and then you get notified when new videos from the channel come out. But thank you all for watching, and I look forward to seeing you on another video again soon. Bye-bye.